Hello class, welcome to Unit 5 Video 1. Today we're going to go ahead and look at the counting principle. So Unit 5 starts out our probability unit. So today you're going to learn to solve problems involving independent and dependent events. So the number of possible license plates for a state is too great to count by listing all the possibilities. It is much more efficient to count the number of possibilities by using the fundamental counting principle. Okay, so we're looking at the fundamental counting principle today. So, some terms that we're going to use as we look at the fundamental counting principle and as we go through the probability unit is an outcome. Okay, an outcome is the result of a single trial. Okay, an example would be flipping a coin once results in two outcomes, heads or tails. Okay, so I would recommend writing down the example. So your example is that you would get two outcomes. Your outcome is either a head or your outcome is a tail. The next thing is a sample space. A sample space, sample space is a set of outcomes. So the total possible outcomes when rolling a die, there are 6. Okay, so if you wrote out the sample space, you would write out 1, 2, 3, 4, 5, and 6. That would be your sample space. All right, so outcome, there we go, and sample space. The next thing is an event. It consists of one or more outcomes of a trial. Okay, so an event is if I roll a die and flip a coin. Okay, so one or more outcomes. So rolling a die, you could get numbers, and flipping a coin, you'd get head or tails. Then independent events. This is where you need to know the difference. Okay. The outcome of one event doesn't affect the outcome of another event. Okay. So the choice of letters and digits to be put on license plate. They're saying that's independent. Because what independent means is if I have to have a letter, and then a letter, okay, what letter I pick here, so let's say I get A, okay, it's independent if I can get an A again, and you can, okay, so as you look at this plate, they have a U and then a U, so it doesn't matter what you have on the first one, all the possibilities are still available for the next one, okay, so in this case, if I was just talking about letters and letters in a letter, there's 26 letters, so I'd have 26 options, and then I'd have 26 again, and then I would have 26 options again. If I was asking how many 3-letter options could I have for license plates. Dependent, though, is different. It's when the outcome of one event does affect the outcome of another event. Okay, so choosing a piece of candy from a jar and without replacing it, choosing another piece of candy. Another thing would be saying, oh, I'm going to make a license plate, but this time you can't use the same digit again. So that means I have 26 to choose from here, and let's say I get U, that would mean I can't have U again, so I only have 25 to choose from here. Then I have C, let's say, and so I can't use U or C, so now there's only 24 letters to choose from. Okay, so that's what dependent would look like. So another thing is independent. I pull a piece of candy from a candy jar, look at it, put it back, then I draw another piece. All the outcomes are still there. Okay. Here, though, I choose a piece of candy from a jar, and then I don't replace it, and then I choose another piece. There's less candy to choose from on the second time, so that makes it dependent. What happened on the first one affects what happens on the next one. All right, let's go ahead and look at example 1. A sandwich cart offers customers a choice of hamburger, chicken, or fish on either a plain or sesame seed bun. How many different combinations of meat and a bun are possible? So, method 1, we're going to solve this using a tree diagram. Well, my first choice I have is it a hamburger, a chicken sandwich, or a fish sandwich? Then, off of each of these, I have a choice of a plain or sesame seed bun. So, how many total options do I have? 1, hamburger and plain, hamburger, sesame. 2, so this would be 1, 2, 3, 4, 5, 6. So, there are 6 sandwich options. Good. Method 2. Now we're going to use the fundamental counting principle. Okay. If one event can occur in m ways and another in n ways, when the number of ways that both events can occur is equal to m times n. So it's a lot easier to use a fundamental counting principle as opposed to listing out a tree diagram, because we're going to be looking at much more complex problems as we progress through this unit. So through the fundamental counting principle, we can just say, well, how many meat options were there? There was 3. How many buns? 2. So there are 6 sandwiches. Then part C on your note sheet says, are choosing a meat and a bun independent or dependent events? They are independent, and the reason they're independent is because when I select my meat, I have the choice of using all the meats. Okay, so there's 3 meats, I have a choice of 3. And then when I look at the buns, there's 2 buns, I still have a choice of all the buns. Okay, so they're independent. So that is example 1. Let's go ahead and look at example 2. To check a voicemail, owners may have to enter a 3-digit code. Determine whether choosing each number is an independent or dependent event, then determine how many codes are possible. Okay, well, if I choose a code, does it say that I can't do 555? No, it doesn't. So in this case, this is an independent because the digits can repeat. Doesn't specify that it can't, so I'm going to say that I can. So I'm picking a 3-digit code. Okay, how many digits are there? So here's where people get confused. How many numbers are there from 0 to 9? Well, there's 0, 1, 2, 3. And let's count how many numbers that is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 total digits, so something to keep in mind. So there's 10 digits, so how many options do I have for here? I have 10. If I can repeat numbers, I still have 10 options for my next digit, and there's 10 for the last. So 10 times 10 times 10, if you want to speed it up on your calculator, it's 10 to the third if you don't know, which is 1,000 codes. So there's 1,000 options. Look at example 3. Carly wants to take 6 different classes next year. Assuming that each class is offered each period, how many different schedules could she have? So is this independent or dependent? Well, if she takes algebra first hour, is she going to take algebra again second hour? No. So this would make it a dependent event. You don't want to repeat classes. So classes cannot repeat. All right, and so she takes 6 different classes. So these are my lines to represent my classes. How many options does she have for the first hour? Well, we haven't picked any classes yet, so there's 6. For the next hour, there's 5, then there's 4, then 3, then 2, and after I picked them all, there's only one last option for the other one. So this is 6 times 5 times 4 times 3 times 2 times 1 is 720 schedule options. If you have any questions on example 3, go ahead and write them down. Otherwise, there's a space on your note sheet for you to write down any questions or concerns you have throughout this lesson. Okay. Example 4, if a garage door opener has a 10-digit keypad and the code to open the door is a 4-digit code, how many possible codes are there? Once again, doesn't say that they cannot repeat, so they can repeat. So that makes it independent, and I'm making a 4-digit code, and there's 10 digits possible. So it's 10 times 10 times 10 times 10, which I can write as 10 to the 4th on my calculator, or I can just say 10 times 10 times 10 times 10 is 10,000. So there's 10,000 codes. And our last example, each player in a board game uses one of 6 different pieces. If 4 players play the game, how many different ways could the players choose their game pieces? So is it independent or is it dependent? So let's say we're going and I get to select first and I pick the hat. And then somebody else after me chooses, can they still pick the hat? No, they cannot. So there are dependent events. What I pick affects what everybody else can. So there's 4 people playing, so 1, 2, 3, 4. The first person that picks, how many choices do they have? They have 6 choices. Now that that person has selected theirs, the next person only has 5 to choose from, and then 4, and then 3. So 6 times 5 times 4 times 3 gives us 360 different ways for those game pieces to be selected. Okay. If you have any questions on this note sheet, please come and ask. Otherwise, you can go ahead and start Unit 5, Practice 1, and have a good day.